The PicoScope 5000 is a USB connected PC-based instrument. Control of the instrument is done through the laptop computer, and display of the waveforms that it's captured are shown on the laptop screen. What we're looking at here is a relatively low frequency sine wave. It's a 9 kHz sine wave, and we can see it clearly on the screen. Looking at it, there appears to be a bit of noise that we can start to see at the peaks of the sine wave. We might be interested to analyze that noise a little bit further. So we could use the zoom control to zoom in on one of those peaks and see what's going on. Now if I freeze it for a moment, you can see actually it hasn't really told us very much more information. We're essentially looking at the quantization levels between each of the bits of resolution of the analog to digital converter. So what we can do with the 5000 series is we're not limited to just acquiring data with 8 bits resolution. We can have higher bits of resolution. So we'll switch now to acquire that same signal with 12 bits of resolution and see what difference it makes. So the PicoScope now has reconfigured itself. It's reconfigured the A to D converters to acquire with 12 bits resolution, and we can do the same zooming in to look at the characteristics of the noise, and now we're starting to see much more information. We're starting to see that the wave shape of the noise that is riding on the top of that waveform isn't random, it's actually triangular. And I can use the rulers to make a measurement on the characteristics of that triangular noise. So we've got a period of about 1 microsecond, so the frequency of the noise is at about 1 megahertz. I could use the horizontal rulers to measure the amplitude. So we've got noise of about 13, 14 millivolts. So by switching to higher resolution, we're learning much more about the characteristics of the noise that we need to investigate to solve that if it's a problem in our design. Now, we can go even further. We can switch, instead of 8 or 12 bits resolution, we can switch all the way to 16 bits resolution on a single channel. And if we then acquire the signal, zoom in further, now we can see with exquisite detail and absolute clarity the characteristics of that noise. And it's perhaps coming from a power supply or crosstalk that is affecting the design, but by knowing the characteristics of the noise gives us important clues as to what the source of the noise is and where we should make improvements to the design to solve the problem.